Okay, so what we're going to talk about now is the if-then and the if-then-else conditional statements. So the way this is going to work is, let's say we had some computer code, and the code says, since we're halfway between New York and Philadelphia, we'll use this example. We'll have an integer called Mets, which will be the Mets score. And the Mets have 6, and we'll have an integer Phillies, which is equal to 3. Okay, so suppose our goal is to print off who's winning the baseball game. If our code said print Mets are winning, followed by print Phillies are winning, what would the output of this computer program be? So the output would be Mets are winning, Phillies are winning, right? That would be the output. No, we don't want that. What we would like is to look at these two variables and make a decision about them. If the Mets have a higher score than the Phillies, we would want to say the Mets are winning. But if the Phillies have a higher score than the Mets, then we'd want to say the Phillies are winning. But we don't want to say both. So we have these two lines of code that need to run not all of the time, but some of the time, right? So that introduces, when you have code that needs to run sometimes, but not all the time, this introduces the idea of an if-then statement. So the way that an if-then statement works is we're going to say if followed by some condition that is either true or false. And if the condition is true, then we will run a certain line of code. So for example, we could say if it is raining, so it is raining is either a true or false statement. If it is raining, then bring an umbrella. But if it is not raining, then don't bring an umbrella, right? So this instruction, bring an umbrella, will only be done if it's raining. If it's not raining, then it won't be done. So a very famous mathematician named George Boole, who lived in the 1860s, so around the same time as Abraham Lincoln here. And he lived in Cork, Ireland. He was the first mathematics professor at the college, it was the Queen's College or something in Cork, Ireland. And he was very famous for what's now called Boolean Logic. That's logic based on statements that are either true or false. And some of the statements can get very complicated as to whether or not they're true or false. So there's a story that says he lived about a 1 hour walk from the university. So he lived about 3 miles from the university where he worked. And in those days, there were no cars or Uber or anything like that. So he would walk an hour each way to work. He'd walk an hour to the college. When he was done, he'd walk an hour to get home. And then one day he was out walking in the rain and got pneumonia. And he passed away 2 days later. So a lot of times you'll see this Boolean statement, if it is raining, then bring an umbrella. Maybe that's in honor of George Boole. But anyway, so what we have here is we basically have our if statement is if followed by a Boolean expression, something that is either true or false. If it turns out to be true, then whatever comes in the then section that code gets run. But if it's false, then it doesn't get run. So this code is optional. Optional based on whether or not this Boolean statement is true. Okay. we could also introduce the if-then-else statement. So, for example, we could say if, followed by a Boolean expression, it is raining. If it is raining, then we're going to use indentations. We have several instructions. One could be bring an umbrella and also wear a hat. That would be if it's raining. And then we could say, well, if this statement is false, if this statement is not true, then we could do something else. We could say bring sunglasses. So this is called the if-then-else statement. Sometimes it's just called an if-else statement because with that, the then, there would be an else. So sometimes they just call it an if-else statement. So the structure is if, followed by a Boolean expression, then you have your then instructions. If the Boolean expression is true, those are the then instructions, followed by the word else, and then you have your else instructions. Okay, so then we introduce, depending on the programming language, we introduce the concept of the dangling else situation. So suppose we had a line of computer code that said, if Boolean expression 1, then if, so the next instruction right after the then is an if statement. If Boolean expression 2, then statement 1, else statement 2. What would need to be true out of the Boolean expressions? What would need to be true to have statement 1 run, and which of them would need to be true to have statement 2 run? And the answer to this question is it's not clear. It's ambiguous. So we're going to use indentation to try to get an idea of the if-then-else structure. So suppose, for example, we have if Boolean expression 1, then, and now we indent, right? So instead of it just being one line here, we're going to indent it to line up the if and the ends and the else's. So if Boolean expression 1 is true, then everything that comes after it will run only if Boolean expression 1 is true. Now the very next statement is if Boolean expression 2 is true, then we'll do statement 1. And if Boolean expression 2 is not true, then we will do statement 2. So if this was, using this indentation, was the interpretation of this line. Remember, this line of code and what you see here are the same thing except we're using indentation. The only thing that changed. So if we could visually see what's going on. If this was the case, the only way statement 1 would ever run would be if Boolean expression 1 was true and Boolean expression 2 was true. And the only way statement 2 would ever run would be if Boolean expression 1 was true and Boolean expression 2 was false, so we go into the end. That's the only way it would run. But another interpretation of this line of code could be like this one in red here. We could say, if Boolean expression 1, then the next statement that comes after it is an if-then statement, not an if-else statement. If Boolean expression is 2, then 2 is true, then do statement 1. But if the original Boolean expression 1, if that was false, then we would just do statement 2. So, in both cases, the only way statement 1 would ever run would be if Boolean expression 1 is true and Boolean expression 2 is true. So that would be the same for each one. But the interpretation, when does statement 2 run, one way to look at it is to say if Boolean expression 1 is true and Boolean expression 2 is false, it would run. Another way to look at it is if Boolean expression 1 is false, it will run. So now the question is, how do we get rid of this ambiguity? How do we get rid of the idea that you can't tell the statement 2? So here's the idea. We could use blocks. and it's popular in programming languages to use brackets to say where your then block of code, block of statements starts and when it ends. So now we could say this: if Boolean statement 1 is true, then open brackets, and then put the whole thing in close brackets, meaning this whole thing happens if Boolean expression 1 is true. So that would be following like this indentation. If Boolean expression 1 is true, then this whole thing is what happens if Boolean expression 1 is true. But if we wrote it this way, if we said if Boolean expression 1 is true, then open brackets. If Boolean expression 2 is true, then do S1. That's the end of this, then. And then independent of that is S2. So that would be like saying if Boolean expression 1 is true, then check if Boolean expression 2 is true. And if that's also true, we'll do statement 1. But if Boolean expression 1 is false, then we'll go down and we'll do statement 2. So the brackets come in and save the day. So there were programming languages that actually use the word then and else. In fact, else is still popularly used. That use that one have this dangling else ambiguity. What became popular with a lot of programming languages was not to use indentation, except now Python uses indentation, but to use brackets to know when things start and stop. Now, if you think about it, you don't need the word then anymore if you're going to have brackets. So in other words, if you say if Boolean expression, well, the next thing after it has to be the then part. It wouldn't start with an else part. Otherwise, you could just use the reverse of the Boolean expression and have an if-then without any else. So it's kind of pointless to have the word then. So we can actually get rid of the word then. We could say if B1, open bracket, do this stuff, close bracket, else. We still need the word else, but we don't need the word then. So that's popular in C, C++, Java, JavaScript, all those languages. Okay. So now suppose we have the Mets are equal to 3, the Phillies are equal to 3, and then our logic goes, we're now going to start using if statements. We're going to say if the Mets score is greater than the Phillies score, then print Mets are winning. Else, if the Mets score is not higher than the Phillies score, then we're going to print the Phillies are winning, right? So we have 2 lines of code, but only one of the 2 is going to run based on whether this Boolean expression is true or false. So the code looks pretty good, right? We know that the Phillies or the Mets, one of them must be winning. And there's no such thing as a tie game. Right? So this would tell us the Phillies are winning, but actually the score is tied. So little hole in our logic. We don't want our Boolean expression to be the Mets are beating the Phillies means the Mets are winning, otherwise any other situation, the Phillies are winning. There could be many other situations going on, right? Game could be 3-3 and it's currently rain delayed. Right? There's a lot of other situations. So let's, so now we're getting into the idea of making sure we got all our Boolean logic correct. So the negation of, the opposite of, Mets are greater than Phillies is not Phillies are greater than Mets. That's not 100% true. So we've got to be careful when we're doing that. Okay. So suppose we had, instead of 2 possibilities based on our Boolean expression, suppose we have multiple possibilities, 3 of them or 4 of them. So for example, we could then make it a series of if-then statements. So for example, we could say if the Mets are greater than the Phillies, print Mets are winning. Otherwise, print nothing. If the Phillies are greater than the Mets, then print the Phillies are winning. Otherwise, print nothing. If the Mets score and the Phillies score are equal, and just one thing here, this double equals is not an assignment. I'm not taking the Mets score and assigning it to the Phillies score. I'm asking the Boolean expression. Is the Phillies score equal to the Mets score, true or false? If the scores are equal, then I can say the game is tied. So hopefully, one of these three would be true, but the if-then statement only allows for one situation if the Boolean expression is true. The if-then-else allows for two possible outcomes, one where the Boolean expression is true and the other where the Boolean expression is false. If we have three or more outcomes, we might want to just have a series of if-then statements. So you have to use your judgment when going through something like this. And if it turns out we had a lot of possible outcomes, 7 or 8 different things could happen, some programming languages allow us to have a bulk, depending on all these different scenarios, what would you do? So, for example, sometimes it's called switch, and we'd say switch, let's say we have the day of the week is a number between 0 and 6. And let's say Sunday is 0, like JavaScript uses this. Sunday is 0, Monday is 1, Tuesday is 2, all the way up to Saturday is 6. Okay, so we could say, well, under many scenarios, instead of saying if day equals 1, print today is a weekday. If day equals 2, print today is a weekday. If day equals 3, print today is a weekday. What we could say is for all the possible cases, we could just enumerate all the cases. We could say if today is 1 or 2 or 3 or 4 or 5, then print today is a weekday. If today is either 0, meaning Sunday, or 6, meaning Saturday, we could print today is the weekend. And then if for some reason, whoever sent us the day of the week didn't give us a number between 0 and 6, we have some bad number, we don't know what to do, we'd say, something's wrong. Right? So now the idea is, it's kind of like you're saying, if this is true, print that. If 2, print that. If 3, print that. If 4, print that. If 5, print that. If 0, print this. If 6, print this. So it's really like a long series of if-then statements to cover every possible case. This is just a switch statement, is just shorthand for a big series of if-then statements. Okay, and then the idea this kind of introduces the concept of a break. Anytime you see break in a programming language that allows breaks, means you go to the end of this structure. So this switch structure ends at the end of the default, and it means jump to the bottom. So we would just print out today is a weekday, and then we would leave. We wouldn't also print out today is the weekend and also print out something's wrong. We would just print the one thing we want to print, and we would leave. We'd break out of the switch statement. Okay. All right. So now, I mentioned this a little bit earlier, but this is an important concept, the difference between equals and double equals. Equals is when you're doing an assignment. You're assigning a value, the value on the right to the variable on the left. So for example, if you were to say A equals 3, one equal sign. If you were to say A equals 3, that means I want to take the value of 3 and put it into the variable A. I'm assigning the value of 3 and putting it into the variable A. But if I say if always is followed by a Boolean expression, something that is either true or false. If A, and I say double equals 3, I am not assigning 3 to A. I'm asking the Boolean true or false question. Is A and 3 equal in value, true or false? And if so, then this will be my then code. So this will not assign A to 3. It evaluates the Boolean expression, is A equal to 3? In many programming languages, like C and C++ and Java and PHP and JavaScript, if you write a statement like this, integer A equals 9, this will assign the value of 9 to the variable A. If on your next expression you say if A 1 equals 3, then print A does equal 3. What will happen here, because you put 1 equal sign, first, all computer code in this Boolean expression runs, and then after it's all run, so there could be many statements in the if. After it's all run, whatever the value of the last statement is, will determine if the Boolean expression is true or false. So what would happen here is the value of A would be assigned to 3. The value of A would take on the value of 3, so the 9 would be lost, it would become 3. And then we would ask, is A true or false? And if A is an integer, if it has the value of 0, it's considered false, and if it has any other value, it would be considered true. So this would evaluate to true. A would become 3, and therefore the Boolean expression would be true, and you would be really confused. Why is my code not working? Okay. So that's one of the most annoying and difficult computer programming bugs to debug. You put in a single equal sign and you meant a double equal sign. Okay. Okay. So true or false? Most programming languages will consider true or false. If you have a string variable, if it's blank, it's false. Otherwise, it's true. If it equals anything, it's true. And a lot of times integer and floating point numbers, if they equal 0, 0 is false, everything else is considered true. So if we said A equals -3, and then we said if A is a Boolean expression, is A true or false? A lot of times the interpretation is it 0 or not 0? And if it's not 0, be true. So the Boolean expression is true. Otherwise, say the Boolean expression is false. What would be the output here? Okay. Sometimes it could be a compiler error saying this is not a Boolean expression, it's an integer. And other programming languages, so would it be true, false, or a compiler error? It depends on the programming language. So it's another thing we just have to be careful of to make sure that we don't get zonked when running our code. So some programming languages do not take into account that the Boolean expression must be something that is either true or false. It could be true, false, it could be an integer, it could be a float, it could be a string, it could be anything you can throw in, depending on how flexible the programming language wants to be. And there's advantages and disadvantages to that happening. Okay, so Boolean logic, and we got a George Boole's picture here. So for the Boolean logic, we have the conjunctive, which is an and, which is denoted by this symbol. We have the disjunctive, or the or expression, denoted by this function, looks kind of like a B. And the negation, the not, which is denoted by this not sign. So for example, we can have a Boolean expression that says, and I'll kind of read it using and, or, and not. So the Boolean expression goes like this. A and, open bracket, B or not C, which is read as A is true and either B is true or C is not true. Commonly written in computer code is like this. If A double ampersand means and, open brackets B, double vertical bars means or. And the exclamation point in front of a Boolean expression means the reverse of it, the not of it. Okay. Okay. So, okay. So suppose we had a Boolean expression like, a Boolean expression like this. P is something that is either true or false. Q is something that is either true or false. And R is something that is either true or false. 3 separate Boolean expressions on their own. Now we want to know if P is true or Q is true and R is true. So sometimes you get into these situations in life where like you're trying to figure out if your team is going to make the playoffs, right? So let's say it's near the last day of the season and you need the Mets have to win today, and either the Phillies or the Braves, one of them has to lose, and you're trying to figure out, yes or no, are the Mets going to get into the playoffs? So this could be kind of like, you know, the Phillies or the Braves have to lose, and the Mets have to win, you know, on the last day. So that's, you know, it's like a little bit of a complicated Boolean expression. So one of the things we can do is to break it down into its parts, and then look at its parts to generate new parts. So for example, the variable P, Q, and R could either be true or false, right? So what do we say? Like if the Mets could either win or lose, or win or lose, or win or lose, or win or lose. The Mets winning is true or false. The Braves winning could be true or false. The Phillies winning could be true or false. And we're going to put this big complicated thing together at the end. Figure out if in the end do the Mets get into the playoffs. Okay, so we would want to take all the possible Boolean outcomes. P could be true or false, Q could be true or false, R could be true or false. So how many different combinations of P, Q, and R could there be? Well, it turns out it's the number of events, 3 events, raised to the power of 2, right? No, sorry, the number 2, the number of outcomes raised to the number of events. So 2 raised to the number of 3. So there's 8 different combinations of how the variables P, Q, and R could come out. So we can write it as what we call a truth table, a table where we're putting in whether something is true or false, and write down every combination. So for example, one combination of P, Q, and R is true, true, true. You know, Braves win, Phillies win, Mets win. Then we can have Braves win, Phillies win, Mets lose. We could have Braves win, Phillies lose, Mets win. So we can write out every combination of all the events that can happen, and there's actually, because there's 3 variables that could either be true or false, 2 raised to the 3, there's 8 different combinations that could happen. So the 8 different combinations are true, 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 false, true, false, true, true, false, false. So these are the 4 combinations that can happen where P is true, and now we're basically going to repeat this for all the cases where P is false. So it's false, true, true, false, true, false, 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 true, and false, false, false. So out of P, Q, and R, the biggest combination is, of all the different combinations, these are all the ones that can happen. Now what we're trying to figure out is what is the value of, P or V and R. Well, the first thing we should figure out is P or V. So let's make a column called P or V. So if we look at P or Q. If we look at P and we look at Q, and we're saying if either one is true, we're going to put a true here. So now we're looking at this is true, this is true, we'll put a true here. This one's true, we'll put a true. This one's true, this one's false. As long as one of them's true, we're going to put a true here. This one's true, bang, true right here. This one's false, this one's true, we'll put a true here. As long as one of them's true, we'll put a true here. This one's false, this one's true, therefore, if either one is true, The last 2 cases, P is false, Q is false, P is false, Q is false. They'll be false and false. So the Boolean truth assignment for the expression P or Q, when you're looking at all the combinations of it, it goes true, 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 false, false. Now, the final expression, our last Boolean expression, what we would like to evaluate is this statement true? Well, this statement would be true if the values in this column are true and the value in the R column is true. So now we're going to go through both of these columns, and we're going to say to ourselves, if there's a true here and a true here, we'll put a true here. We'll fill in this column by looking at these 2 and making sure they're both true. So this is true and this is true, therefore this is a true. This is true, this is false, therefore this one's false. Both true again, we get a true here. A false and a true, that makes a false. Any way you see a false, we get a false here. A true and a true gives us true. A false and a true, this false makes that one false. True and a false makes that one false. A false and a false makes that one false. So what would have to happen for the Mets to get into the playoffs? We would need the Mets to win. If the Mets win and the Phillies and the Braves both lose, we're in. Here the Mets won, but unfortunately the Phillies won. All right, never mind. So let's just follow the true and the false thing. So here, with this one being true, and this would be a case where the Mets lost, so therefore they didn't get into the playoffs. So all the times when the Mets lost, they automatically didn't make the playoffs. And the ones when they did win, they also didn't make the playoffs if the other two events, one of the other teams they needed to lose didn't lose. If the other two teams won, then they wouldn't get in. Okay, the point being this. We could have very, very complicated, because they could grow infinitely long, very, very complicated Boolean expressions. And you just have to break them down into their separate parts. So you take all of the original inputs, write them out in a truth table, write down every combination, and then every component of your final Boolean expression, make a column for those, and just keep taking the true and false values, generating the next column until you finally get to the end of your Boolean expression. And once you get to the end of your Boolean expression, then you know how you finally evaluate it. Okay.